Let's move on the next session. The next topic of the session will be advanced materials for additive manufacturing. The expert for next session is Professor Niraj Bala Mam. Ma'am, I'm audible. Have you joined?
Yes, sir, I have joined. Am I audible to you?
Thank you, ma'am. Thank
Yes.
you. Doctor, the expert for next section is Madam Niraj Bala. Dr. Niraj Bala is presently working as a professor in entrepreneurship development and industrial coordinator department at National Institute of Technical Teacher Training and Research NITTR Chandigarh. Her area of specialization are entrepreneurship, intellectual property rights, surface engineering, and manufacturing practices. She was awarded Best Engineering College Teacher Award for Punjab State for year that 2012 by Indian Society for Technical Education ISTE New Delhi. She was nominated for Best PhD Thesis Award by NACE National Gateway India section and awarded runner-up award. She got Srimati Sheila Baya a national award in 2015 for outstanding contribution for technology advancement in the field of mechanical engineering by IEI India Udaipur local center. She successfully carried out research projects sponsored by government. She has been granted 1 patent. She has co-authored 2 textbooks and 6 book chapters. She has to her credit around 100 papers published in the journals and conferences. She has guided 9 PhD candidates and 30 MTech students. She is the co-coordinator of MOOCs titled Institutional Management for the Entrepreneurship. She has coordinated CPSC and NITTR Chandigarh International Collaborative Region Program, where participants from 10 member country participated. Thank you, ma'am, for joining us. Over to you.
Thank you so much, Dr. Gurbez, for such a wonderful introduction. And thank you for giving me this opportunity for delivering this session on a very important topic, that is 3D printing. So, sir, I think we will have to stop sharing the presentation so that I can share it now.
Yes, please, ma'am, you can.
No, already Dr. Hitesh presentation is there.
Yeah, just hold for a moment.
Shall I try?
Yeah, you can.
Okay.
We have given the host right to you, ma'am. Please.
Okay. So, dear participants, once again, I am thankful to the authorities of Amritsar Group of Colleges and especially Dr. Gurbez for giving me this opportunity for being part of this 6-day faculty development program, Atal online program in collaboration with All India Council for Technical Education and Amritsar Group of Colleges. So, sir, my PPT is visible to you?
Very clear, ma'am. Very clear.
Okay. So, shall I start then?
Yes, please, ma'am.
So, okay, so this is the topic which I will be discussing with you, advanced materials for additive manufacturing. So these are some of the topics I will be taking. Now, first of all, though it is not the first session, Dr. Hitesh was taking an introductory session with all of you, but I mostly take this first slide. Why, first of all, do we need to study this 3D printing or additive manufacturing? So, dear participants, we are part of Industrial Revolution 1, 2, 3, and 4. If you are aware, the Industrial Revolution began in the 18th century when steam engines were invented, and steam was used for various purposes, for machines, for locomotives. This was followed by the second Industrial Revolution, that was 1870s, when the assembly line, production line started. Then third revolution, when computers and automation started, that was our third revolution. And today, participants, we are a part of the Industry 4.0. And if you see the various technologies which are driving Industry 4.0, amongst the other technologies, you will see that additive manufacturing is one of the core technologies which is driving our present industry. So it is essential that we understand, we work on this additive manufacturing, and we introduce this technology to our students, to our technical students. So additive manufacturing, also known as 3D printing, I will not go much in detail because of the introduction. I will be mostly discussing the topic which has been given to me, that is what are the different materials which we use in additive manufacturing. But just a brief introduction, 3D printing is also known as additive manufacturing because we are not subtracting any material like other manufacturing products. We are adding some materials in this, so we call it as additive manufacturing. Initially, when it started, it was so fast work that they started calling it as rapid prototyping. And the basic function of this 3D printer was to make prototypes, like small models. So that is why the other name which is used for this is rapid prototyping. It is also called 3D printing since it is additive in nature. So it is also known as additive manufacturing. So any of these names may be used. So sir might have already told you the process. It is a very basic generic process to print by using 3D printer. If you see this graph, this is a cup I have shown you in figure 1, and 0.8 is the final cup. So basically we want to make this cup which is shown in figure 8. What you have to do, you have to just make a drawing of a cup, 2D cup, render it, convert it into a 3D cup by using AutoCAD, any modeling process. So this figure, you will just convert it into a format which we call as STL, like we have PDF, PNG and all. So we convert it into an STL format. Then we feed this with the help of pen drive, you feed it into a 3D printer. The 3D printer will automatically take some coordinates. It will make some calculations. And you just have to give the drawing model and you have to feed the powder or the raw material with which you have to make the cup. The final cup will be available with you as shown in position 7. So this is a very simple process. You just have to make a drawing, convert it into STL, feed it to the machine. The machine will make some calculations and you will get the final cup here. After that, you do some paint, some post-processing, and you remove it from the plate. This is how you obtain by using a simple 3D printer. These are the 8 stages of a 3D printer. So now we have different types of 3D printing processes for which different types of materials are used. So one simple method is FDM. Sir was also talking about this fused deposition modeling. What do we have in fused deposition modeling? In this, if you see in this process, you will see 2 different types of filaments of 2 blue color. One is the dark blue and other one is the light blue. The dark blue color is your input material. The light blue material is your support material to provide you the support. So in this case, in fused deposition modeling, the material is provided in the form of a filament inside the 3D printer, and layer by layer, the final product is obtained. So what type of materials are printed using this FDM process? You can see this small presentation model. Some food applications are also used, and those which are having high heat applications, for those we use this fused deposition model for making the product. So what are the features of this fused deposition model? It is very low in cost. The speed is high and a very simple process is there. However, if you see, the mechanical properties are weak, as you can see from this figure, and the surface finish is not very good. So poor surface finish, and fiber reinforced composites can be used. In order to avoid that, we can have fiber reinforced composites. So FDM uses, from FDM process, you can prepare fiber reinforced composites and you can make different types of materials. So fiber orientation, bonding between these are the main challenges that arise in 3D printed composite parts. So this is one method, that is FDM. Then powder-based methods are also there, in which the feed material is powder. If you see the previous method, it is in the form of wire. In case of powder bed fusion, the feed material is in the form of powder. Mostly, if you see under this powder bed fusion, we get some metallic, it is used for metal printing mostly. So one method first is known as selective laser sintering. Another one is selective laser melting. Then we have direct metal laser sintering and electron beam melting. So these are almost same types of methods, only the source of heat is different. So what we do in selective laser sintering, we do not fully melt the material, but we just heat it at a temperature so that the fusion of the powders may take place. So basically how it occurs, I think I have made a diagram also. So what actually happens inside this, only two input you have to give. One is that CAD model which you have to prepare, 3D CAD model. So you prepare the 3D drawing, convert it into STL format, and you feed it to the printer. The powder is in the form of a metallic powder is there. So basically how it works, the metal layer is formed on the bed of this 3D printer, and the bed is moved down. Again, another layer of material will come. A source of heat will cut the required shape. So the required shape is cut by using a source of heat. So this particular shape is obtained by using this laser. So if you are using laser, selective laser melting, we will call it as. So the particular shape is obtained. If you see here, the particular shape is cut with the help of that laser. So layer by layer, what is actually happening? This table is moved downward. A layer of powder comes, then the laser comes. Laser will cut the required shape. The table is lowered down. Another layer is poured. Likewise, layer by layer, additively, you obtain the specific shape. So this is the mostly used for the metallic powders. So if you are using laser melting, then it is called selective laser melting. If instead of laser, if you are using electron beam for cutting, then it is known as electron beam melting. So depending upon the source of heat, what you have used, we have these different types of melting treatments: selective laser sintering, selective laser melting, direct metal laser sintering, and electron beam melting. So this is the entire process. Can you see here of powder bed fusion? This is the method which we have used. So what are the advantages of this powder bed fusion? There is reduced material wastage, improved production development times, capable of building functionally graded parts, fully customized parts can be made, good resolution, effective recycling of unmelted powder. So the powder which is left, which is not converted into a 3D model, that can be again recycled. So this is again, when we talk about sustainability, this is again a good thing that we can recycle the powder. And in this case, we can also use different types of materials like ceramics, glass, plastics, metals, and alloys. Then elimination of need for machining fixtures. We do not require much fixtures. You just give the shape and we get the required shape. So there is another type, inkjet printing. This inkjet printing is, one example is given here. In this, we use some oxides like zirconium oxide powder. A suspension is created in water and it is deposited in the form of droplets. As you can see on the figure, in the form of droplets, by the injection nozzle on the substrate, we can obtain this by using inkjet printer. I will show you one inkjet printer also we have at NITR Chandigarh. So where do we use this inkjet printing? In this, wax-based inks are used. They are melted and deposited on substrate. Then some inkjet printing is also known as counter crafting. So these are the different two main types of inks are used: wax-based and liquid suspensions like zirconium oxide in water, or some wax-based inks are used in case of inkjet printing. So another method which we used is stereolithography. So dear participants, this is the oldest, or we can say the first type of method which was from where the 3D printing concept started. Stereolithography is actually based on the concept that a monomer, we know how do we make a polymer. From a monomer, we make a polymer. So in this case, a monomer is used, and with the help of electric beam or with the help of source of heat, the monomer is converted into a polymer chain. So initially a monomer part is used, which is further converted into a polymer. So polymerization process takes place inside the resin, and it is solidified, and we obtain the final product. So these are certain products which are made from using stereolithography. You can see these are two products, the chess products which are used. So these are made up of polymer. Plastic materials is used. So rapid tooling patterns, snap fits, detailed parts, presentation models, and where high heat applications are required. So these type of products can be made by this process, which is known as stereolithographic process. So there is another process. I will be showing you a number of applications. I am just telling you briefly the various 3D printing processes. So we have another type, that is direct energy deposition. This is again a very common process for mostly for superalloys, where we want to 3D print superalloys. There we use this direct energy deposition process. This is also known as laser engineered net shaping, lens stem. It is known as laser solid forming, LSF, directed light fabrication, DLF, DMD, direct metal deposition. This is also known as electron beam. So different names are there. So in this, the source of energy is again laser or electric beam. Basically in this direct energy deposition, first of all, the substrate on which you want to make the a product, that is heated, and the feedstock material is also melted. So the feedstock material is melted on the substrate, and both are fused together. They are deposited and fused together. So by fusion, by direct energy deposition, the powder is moved, the material, 3D printed material is obtained. So this direct energy deposition also has a number of applications we will see in the coming slides. So the difference between DED and selective laser melting is that no powder bed is used in DED, and feedstock is melted before deposition. Right? This method, DED can be combined with conventional subtractive processes also. So what are the different materials which are used in direct energy deposition? Titanium, Inconel, then stainless steel, aluminum, and related alloys for aerospace applications. So this DED is a very common process used for aerospace applications. Then there is another method which is known as laminated object manufacturing. If you see here, it is in the form of lamina. Laminated actually means, lamina means layers. So in this case, if you see on one side, we have a filament. You can see this filament. This filament is rolled here. This filament, with the help of rollers, will go on this table, and the remaining filament will be going to the second side, other side. So with the help of a heat source, laser or something, the specific shape is cut here. So this layer of this filament will be cut over this. The table will move down. Again, next layer will come. Likewise, you can deposit layer by layer. The particular shape is cut with the help of this laser. Participants, have you understood this? Laminated object manufacturing. So basically, in this case, a sheet is spread over this. A sheet is there. In the form of laminated sheet is there. So a new sheet comes, the specific shape, whatever is the shape we require, that is cut with the help of laser, and layer by layer you get a final product is obtained, final model, prototype, or whatever product you are making. So this is basically based upon the sheet material. Fresh sheet is used in every time. So these are some examples. You must have seen these fruit and bowls, 3D printed fruit and bowl 3D. These are being made with paper. So you can use this fruit and bowl 3D printed in paper. So dear participants, just quickly, I have shown you various processes and their materials used. The basic purpose was so that when we are understanding the applications, you have some idea of the process which we have used. So stereolithography finds application in lithium disilicate glass ceramic, fabrication of heart valve scaffolds, Then fused deposition modeling is used for drug delivery pattern making. Powder bed fusion is used for smart parts, lightweight robotic parts. Selective laser sintering is used for biodegradable polymers, rapid tooling. Binder jet, another method. Direct energy deposition is used for preparing stainless steel, preparing automotive dies. So the use of 3D for making models. Why we are using 3D printing? The first applications of 3D printing was for models only, because they are very quick. You just prepare a drawing, feed it inside the machine, you will get the final product. So it was very easy process and quick process. So that is why initially the 3D printing process was for models, making models or prototypes or small products. So because of its 3F means form, fit and function. It could easily, you can easily make the required model. Now let us see the various materials which are used or various applications of this 3D printing. Aerospace, previous Dr. Hitesh was also talking when I joined, he was also talking that it is finding applications in aerospace. Why do we justify for aerospace? Major applications are in aerospace, and I will show you few slides where it is now basically used for biotechnology. Why aerospace? Because see, I will show you one 3D printer which is there at Knitter. It is very costly. The cost is very high. If you talk about mass production, if you want to mass produce a product, then this 3D printing is comparatively expensive. But we know that aerospace is that application where cost is not there, but we want to make the planes lighter in weight, safer. So there the cost is not a big question. So there 3D printing has been used to quite a lot of for various parts of the aeroplane. So 18.2% of the total additive manufacturing market is with the aerospace industry. So it is ideal for aerospace because of complex geometry and the materials which are used in aerospace, they are so strong that their machining is very difficult. It is very difficult if you machine those materials, those alloys, and we require customized production and we require on-demand manufacturing. Plus, last very important thing, high performance to weight ratio. So because of these applications, these are 3D printing is used for aerospace. So it has been widely applied to produce spare parts. So 3D printing is a good solution for the procurement of such spare parts. So which type of materials? Nickel-based alloys is more preferred due to the tensile properties and oxidation and corrosion resistance and damage tolerance. So it finds a lot of applications in the aerospace. So you see here Vulcan 2 demonstration nozzle it is 50 kg of DED material has been used in the first application. This is one of the aerospace. Then in the second figure, you can see titanium brackets, additively manufactured titanium brackets. So these are some of the applications in aerospace. Similarly, additive manufacturing finds a lot of applications in automotive industry. So wherever their structures are complex, see, machining of complex structure is also difficult. So there you can go for 3D printing. Local motor has 3D printed electric car. Local motor they made in 2014. They also extended the wide range applications of 3D printing. They call this bus as OLI. Then OLI is a driverless, electric, recyclable, extremely smart 3D printed bus. Then Ford is the leader in the use of 3D printing. They also apply 3D printing technology to produce prototype and the engine parts. Ford is also using. Then BMW is also using to produce hand tools for testing. Audi collaborated with SLM to produce spare parts. Then many other automotive industries have used 3D printing technology to reduce, because it leads to reduction in wastage and as well as consumption of the material. So it reduces cost, time, therefore it allows for test new designs in very fast time. So these are the two automotive applications, Bugatti's 3D printed brake caliper. And in the right hand side, you can see a functional alternator bracket printed using SLS nylon. This white part, this has been made by using nylon. So here I will show you, let me enlarge this figure. Here I will show you one automotive application. If you see, let me enlarge it a bit. So these are the various applications, 3D printed parts. You can see it from here. The green part is the currently where 3D printed parts has already been used, and the blue marked parts are the places or the components which in future will be replaced by 3D printed. Currently they are not 3D printed, but in the future they will be replaced by 3D printed material. So if you see this green part, the exterior and interior trim, the bumper windbreakers, they have been additively manufactured with selective laser sintering, and the material here is polymer. Then if you see here, the second part, fluid handling. The fluid handling is also for pumps and valves. Inside these pumps and valves, they are made by selective laser melting and electron beam melting, and the material for this is aluminum alloy. And again, in this manufacturing process, you will see the prototype customized tooling investment casting method has been used, fused deposition modeling, inkjet selective laser sintering. In this, the material is polymer, wax, hot work steels. Then in the exhaust emission part, the cooling vents, they have been made using selective laser melting, and the alloy used is aluminum alloys. So all these green parts in this particular car have been done by 3D additive manufacturing processes. But in future, the powertrain, drivetrain, that means the engine components, that is selective laser melting can be used for materials, aluminum and titanium alloys. And here the frame, body, doors, these the body panels, they are also selective laser melting and aluminum alloys can be used. Then body in white, this part, then certain electronic parts also on the dashboard that can be used by selective laser sintering, such as embedded components such as sensors, single part control panels. Then for the wheels also, tires and suspension, the tire suspension springs, selective laser sintering, inkjet selective laser melting, and the materials polymer, aluminum alloy can be used. The interior and sitting and interior dashboards, seat frames, they can be also done by additive manufacturing. So the material they are used will be polymer. So dear participants, this picture on a whole, it gives you an entire detail on how the 3D printing has changed the picture and how so many parts of an automotive can be printed by using this 3D printer. So before moving further, I would like to interact with you all. Are you there with me? Any questions from your side? My PPT is okay. My PPT is visible now to everyone? Okay. So going back.
Yes, madam. PPT is visible. You can continue.
Okay. So another application. So here till here we have mostly covered the mechanical applications in aerospace, in automotive. Another application is in construction. You will be astonished that architectural applications, they represent 3% of the total additive manufacturing industry. However, this is still in new, but a lot of applications are there in construction. Concrete is the material. The concrete material which we use for building construction. So concrete material has been also used as a material for 3D printing. So here I have shown these two pictures. You can see this is a type of a big jet type of printer. So this printer works with a robotic arm. You can take it on site where you want to make a 3D printed product. So this house, I will show you some photos where the complete house is made by 3D printing. In the end, I have some applications which were where 3D printers were used in the COVID also. So if you see here, this is a robotic arm. So they are printing it, 3D printing using the raw material as concrete. So this robotic arm is 3D printing this here. So digital construction platform, MIT University is using this. Then this is very common, very lot of decorative pieces, 3D concrete printing. So this machine, this is a decorative piece to be used in home or some other applications. So this is again another 3D printer. This is doing the 3D concrete printing with this printer. So the totally 3D printed houses have been built. So this is the first 3D printed house known as by Dusar architects. And this second one is the 3D printed house by Vincent. So can you imagine? This has been totally made by 3D printing. So these two houses. So I think you must not be aware that 3D printing is used in food industry. Any one of you was aware that we are using the 3D printers in food also? So there is a growing demand for the development of customized food. If you have some special needs, like some athletes, some children, some pregnant women, patients, they have some special nutrients. So these types of food can be made by 3D printing. So development of customized food must be conducted in detail. So food layer manufacturing, also known as 3D food printing, is used. Let me show you how. But see, there are certain types of food which you can easily print. For example, like we have these sugar, chocolate, puree. So these type of food which can flow easily, they can be easily 3D print. They can be printed easily, like pasta sauce, pizzas. All these can be easily printed by using 3D printing. So this technology is a high energy efficiency technology for food production. So you can produce healthy, clean food, more hygiene food, because you are not touching it, by using this 3D printing. And if you want to make some special diets or customized food, there also it has been used. So what is the basic fundamental behind this 3D printing? If you see here, first of all, you will divide the food into two types. One is known as printable food, other is non-printable food. Printable food means which can flow, like gels, jams, these type of materials you can easily print. Non-printable food means like you have wheat, rice. It is very difficult to print them because they cannot flow. So these type of foods, first of all, you will convert them into printable foods by mixing them in some particular gel or in some particular type of sauces, so that they can be printed. So first of all, you will prepare the ingredients. Like I showed you in the very first 3D printing, only two things are required. One is the drawing, second is the raw material. So here the raw material will be food. If it is already a printable food, okay. Otherwise, you convert that food. If it is a fiber, you will mix it with some jelly or something so that it can flow easily, because fiber as such cannot flow inside the injector or inside the nozzle. So first of all, you prepare your ingredients and prepare a proper food which can flow. So this is pre-processing. Simultaneously, you prepare, if you see this side by, you prepare a CAD file, whatever shape of the final food you want, you prepare a 3D model of that. You convert it into STL file and you put it inside the machine. So this is a small 3D printer shown here. You can see these two are the bottles which are containing the food. So inside this, you will feed to the printer head, you will feed the drawing. From above, you will get some material, raw material will be added here. Here you will have the drawing. Yes, anybody asking question? So somebody is speaking.
Hello, yes, mute yourself, please. Hello. Mute yourself.
Participants, kindly mute yourself.
Kindly mute yourself. Who is disturbing?
Okay. So from the printer head, you will give the file, and here you will get the raw material. So from the nozzle, the final product will be obtained. This is, you can see this small product. This is a 3D printed product. So whatever post processing, like in that we do painting or post processing, some heat treatment. You want to fry it, boil it, bake it, steam it. So whatever post heat treatment is required, you can do the post heat treatment here. But finally, your 3D printed food will be prepared. So this is how we obtain these 3D printed food items. So these are different shapes. This is how now they have started using 3D printing for the food items also. So this is the schematic of how this 3D printer works, food printer works. So these are your arms. This is the motor, and this is the material will be supplied here. And this is a nozzle. So this is a compressor unit, and this is the printing platform. The final product you will obtain on this printing platform. So dear participants, one major application of 3D, most major application of 3D printing is in biomedical application. Why we talk about biomedical application? Because the cost of the material is justified when we are talking about any part which has to be used in our body. Secondly, each person has different shape, different size. So when we want to make some product, some part for our body, then we can customize it by using 3D printing. So let us see various applications of 3D printing in the biomedical or simply medical sector. So here I have shown you bioprinting tissues, surgical tools, then surgical models, custom-made implants, prostheses, then customized prostheses. So these are some of the applications of 3D printing in the medical sector. So in biomedical, it is a branch. What is biomedical? It is a branch of technology that deals with the production of all material, apparatus, and devices that can be used for diagnosis or treatment in the medicine. So artificial kidneys, heart, dental implants, knees, prostheses, lenses, pacemakers, and hip joints. All these are the applications of biomedical plants. Then unit cost remains constant for all products since special tooling is not required. This expense assessment forms the basis for this method. So maximum exploration of 3D printing is in the biomedical field. So I have drawn one better figure. So these are the different types of biomaterials, because the topic for our presentation is the materials for 3D printing. So here we will see this slide covers all the different types of biomaterials, different materials which are used for bioimplants. So there we have synthetic or polymeric based biomaterials. You must not be knowing many names. These are all the polymeric based materials. If you see here, ABS, which is known as acrylonitrile butadiene, then polyacetic acid, then PEEK is another material, polyether ketone, PCl, then poly-D-lactic acid, PDLLA, and polybutylene, then polypropylene. These are certain polymeric based materials which are used in 3D printing. Then we have ceramic based materials, hydroxyapatite, tricalcium phosphates, and silica. These are also used in this. Composite materials, these are polymer based, composite made of hydrogel, then ceramic based. Then hydrogels which are used as bioinks. These are agarose based, alginate, collagen based. You must have heard certain names. Silk based, gelatin, cellulose based, cell aggregates, and synthetic biomaterials. And all of you are familiar with this metal and alloy based materials which are used. Titanium alloys, only 3 different types of metals are approved by FDA, which can be used in our bodies. One is your titanium alloy, especially Ti6Al4V. Second material which is approved by this FDA is stainless steel 316L. And other is the cobalt chromium. So all other, apart from these, they are not approved by FDA to be used in our body. So these are metals and alloys. Participants, this single slide gives you the details of different types of materials which are used for bio applications. Any doubt, anything till now? Anyone wants to ask something? You are we are almost covered half the lecture. So if you have any questions, anything from your side, you are most welcome. In the end, I will give you one link of a paper. So I have taken this from one of my paper we just published, I along with two others. We published one paper on applications of these biomaterials, 3D printed biomaterials. So I have taken these diagrams from my paper only. I will give you the link if you want to refer to these biomaterials in detail. So let us understand and let us see different types of, the first one we covered here was the polymer based or synthetic materials. So the polymer based materials, they find applications in cardiac tissue engineering, drug delivery system. I will show you details also. Skin tissue engineering, bone tissue engineering, cartilage tissue engineering, and corneal tissue engineering. So all these polymer based materials which we have listed here, ABS, PLA, PEEK, they are used for these applications. Then the second is bioceramic based 3D printed scaffolds are used in different biomedical areas. If you see here this diagram, it is a complete diagram showing you the entire cycle. This is a 3D printer. Using this 3D printing machine, we have prepared this ceramic scaffold. You understand scaffold, it is sort of a network. Scaffold is it is a type of mesh, like you have mesh like jali and mesh. So this is like that scaffold. So these are the different applications of this scaffold. These are used in drug delivery. Then these are further used in cell isolation. I will show you this from another figure, how we are actually making the how we are using this in tissue engineering. So gelatin, bioglass, inert alumina, ceramic. So this entire diagram gives you the different applications of bioceramic based 3D printed scaffolds, different biomedical areas. So these are the 3D printed composites. So this next figure, this shows you the 3D printed composites. In this 3D printed polymers, this is your polymer. This is the base material. By using this polymer, we have made a 3D printed polymer here. And using this polymer, we have made this composite. So, and further it has been used for making 3D printed composite. So these are the various 3D printed composites for healing, for sensing, thermal, circuitry, magnetic, and electrical applications it has. So then we have important properties of bioinks. If you see here, bioinks for 3D printing, these are used for, I will show you the applications of bioink in the next slide. So another one is biomaterials applications. Metals are mostly used, orthopedic screws, dental implants. These days, we know the implants which you are getting done in your teeth, they are also done by 3D printing. We know that the screws which are put inside your teeth, suppose you want to replace one teeth, so that is also done by dental 3D printing. Then bone replacement and heart valves, they are also made by ceramics. The drug delivery devices, they are used by the material for them is polymers. Then composite materials, they are used for making biosensors, implantable microelectrodes. So these are all the applications in the biomaterial field. So dear participants, here I have shown you the actual picture of metallic orthopedic implant. Figure A is the implant made from porous tantalum. Can you see here? The second one is this figure, this B figure. It shows you the stents which are put in the in your heart. Stents. These are made up of zinc metal. Both these are 3D printed. Can you see here? So these both materials, these are done by 3D printing, metallic orthopedic implants by 3D printing, and these are the stents which are being 3D printed. These are made up of zinc material. So another application is a very new application for this 3D printing is like we are administering some medicine inside your body, like insulin and all. Some people who are suffering from blood sugar, so they have to inject themselves with insulin. So this is a new method of injection. Microneedles are used for administration of medicine. If you see here, these are 5 different types of microneedles prepared by 3D printing. The first one is totally solid microneedle. The second one is drug-coated microneedle. The third one is hollow microneedle. And this one is dissolvable. And the last one is hydrogel-based microneedle. So first one, if you see here, when it is inserted inside your body, this solid microneedle, it will release the medicine inside your skin or whichever part it is inserted. So this is a new way of administering medicine, like you have insulin and other methods are used. In the second case, so in the first, in the solid microneedle, it will go inside and it has the medicine inside it only, and it will produce the medicine, these dots, when it is inserted inside the body. The drug-coated microneedle has the drug in the front of the microneedle. So the drug is coated in the on the microneedle. This blue part, this is showing that it has been coated by the drug. In the third type of microneedle, it is a hollow microneedle. Inside this, there is drug. It is hollow. When you put pressure, then the drug will come in this form. Can you see these 3 bubbles? So this is the formation of drug. This is how the drug will be administered inside the body. The fourth type is dissolvable microneedle. That means the microneedle will slowly start giving medicine, and it will get dissolved, the microneedle. Another type which is used is hydrogel-based microneedle. Hydrogel-based microneedle will release this hydrogel inside when it is pushed inside the body. So you see the drug delivery, or you can say the method of administering the medicine inside the body is also done by now this 3D. So these microneedles have been made by 3D printing process. So lot of study is being done in different fields inside for applications in our body also. So dear participants, I have been speaking for almost 1 hour. If you have any questions, I have few more slides to go. But if anybody wants to share something, you can write in the chat box, or you can speak also if you are allowed. So anybody wants to say something, ask something before I move further to my next slides, or want to give any input, you are most welcome. Just a moment, let me put my charger on. So let me put my charger on. I might not lose the battery, but let me present also. So dear participants, we have my presentation is visible to all of you now?
Yes, ma'am.
So these are the 5 different types. Laptop bag is there? Okay, leave it, no problem. So 5 different types of microneedle administration techniques. These are the latest techniques. Some other applications, surgical applications. I hope I have unmuted myself. Some other, let me switch off the camera. I don't think I need the camera. I will open it in the end. So some other surgical applications include 3D printing. So in surgical applications, you see when you are studying some complex parts, there we want to see the imaging want to make some anatomical structure. So it is very easy to make it. It is very easy to make with the 3D printing. So here, this is one part they have made for understanding the problem, for understanding the body parts, for the study purposes, and also for understanding the surgical parts. So 3D printing is used for hearing aids also. I will show you these 3 different applications. The first one is 3D printed liver. You can see they have printed it totally 3D printed liver is there. The second one is your kidney model produced by additive manufacturing. So it is very easy for the students or for the doctors who are studying or those students who are doing MBBS to understand the structure by using this part. So the third one is another application is in hearing aids. So this is the third application in this hearing aid part. This is also made by using 3D printing. So these are the 3D printed organs which have been printed by using 3D printing. Then various drugs also. That means the tablets which we eat, the capsules which we eat, the different geometries are also made by using 3D printing. So here different types of drugs 3D printed have been used by using this 3D printer. Now this is again a very unique application. There was this this green one is your 3D digital reconstruction of a skull defect. So one person, he had this defect. Can you see here, white one? So they wanted to repair this defect. So this skull there, the defect was there. So they made a 3D printed skull, and then they made a skull model. Then they made a implant by using EBM method, this implant, and then they tested it by putting this on the skull. So before actually putting on the actual part, because you are not sure how to make it, so they made a 3D printed part. They did a 3D reconstruction, this is the titanium implant which they made, and then they put it inside the model. So lot of when there are some accidents, somebody is facing something happens. So there now lot of places they are actually producing the parts by using 3D printing. So these are another applications, some patient-specific implants. This is what I told you in the beginning, that especially the bio implants, they are used in human body because suppose I want to get a knee replacement. So my shape of my new knee will be different from the shape of somebody else's knee. So the advantage of using 3D printing is that the particular shape can be made by using this 3D printing. So we can obtain that particular shape. So these are different parts. These the hip stem, different body parts, which are made patient specific and made by using 3D printing. So dear participants, here I want to tell you one very unique application of 3D printing. This is most of you are aware that 3D printing is used for making 3D body parts. Suppose you have an accident, you must have heard, okay, the doctor says you will have to have a rod will be put to in order to keep your leg straight. So they do some surgery, they put a rod, and then after your bone has rectified, they will remove that rod. So metallic implants are very common, then stunts are used. These are very common. But dear participants, another application of this is in the tissue engineering. A very new application is in the tissue engineering. What they are actually doing, even the tissue means the body part which is damaged, they replace it by the 3D printing. So what they do, suppose some tissue, this part is defective. So by doing biopsy, they will isolate the cells from your body, and then they will grow your cell outside your body by cell culture. And then in order to provide the strength, the scaffold will be made by using 3D printing. Like I showed you few scaffolds in the previous slides. So the isolated cell is grown outside. The scaffold is there in order to provide strength. The cell is, this is to give the mechanical strength. the tissue is grown on the scaffold, and then we replace this new tissue with the old tissue. Old tissue we have removed. Again, we will implant this tissue inside the body. So this is very rare now, that they are growing your body part outside in the inside the lab, and then they are putting inside your body. This is you must have heard that in certain cases, when a new child is born, then many hospitals, they ask you if you want to keep the stem cells of your baby. So many people, they preserve the stem cells of their baby. The purpose for that is that in future, if that child, he has some disease, he faces some problem, then they can grow that cell and they can replace the damaged cell with this stem cells. So that is the purpose of preserving the stem cells. Many people these days, the hospitals, they take by paying some money, you can store your stem cells, keep them safe inside the hospital. Have you heard anybody about these stem cells? So that is, yes. So that is the reason they keep these stem cells, because now you can grow the tissue also. So participants, the biotechnology field is really going far. Now you must have heard about this CRISPR theory, that they can also modify your genes inside your body. They have started modifying your genes. Even I have heard that last year when we visited one of the museum in UK, that was a museum of dinosaurs. So they said that what we are going to do, we will take the DNA. They found some teeth or some nails or teeth of dinosaur. So they had preserved that teeth, and they said that from the teeth they will remove using that DNA of the dinosaur. They will grow that DNA or genes inside the lab. Then they will implant that inside some big animal, let us say an elephant or something like that. Likewise, they are trying to produce or reproduce, let us say, dinosaurs. So this type of, in few years, this is the theory which they will be using. So previously, that CRISPR lady who produced that theory of CRISPR theory, that we can modify the genes. That means the genetic problems which we are facing, like sugar and other, that can be now solved by use. So basically, they remove or they modify the genes. You must have heard about that. So this is a very vast field, that is tissue engineering, where 3D printing is playing a big role. So these are certain other applications where some animals, if they have some problem, their leg problem or other problem, so by using these 3D printing, they have leg prosthesis. Then penguin whose foot has been amputated, that has been replaced. So kitten legs, so they are using 3D printing. So dear participants, this is the future. By 2026, you will see the field in presently the use of 3D printing in external wearable devices is this much. It will be, I think, I don't know how many times, 3-4 times it will increase. Clinical study devices also it will increase. Then for implants, it will be almost doubled. In tissue engineering, it will be almost 3 times by 2026. So this will be the market share of 3D printed products in biomedical applications. So I will just give you few slides, last few slides of 3D printing, how it was used to fight COVID-19. Dear participants, we know during COVID, there was even an advisory from World Health Organization that there were certain things which had fallen short. So their 3D printing was widely used for making PPE, that is personal protective equipment. Then they were used for diagnostic equipment, and they were also used for critical care equipment. So these face masks, all this blue part which is shown there, so these were made by using 3D printing. Then the mask body, filter box, all these parts, they were made by using 3D printing. So even these adjustable mask adjuster, that was made by 3D printing. Then another mask, 3D printable stoppage face mask. So all these applications, the 3D printing was used during COVID. Then we are also aware that ventilators, there was scarcity of ventilators. So a lot of parts of the ventilator, then they were printed by using 3D printing. Then these swaps, anybody remember what these swaps were used for? For taking the sample. For taking the samples, lot of swaps were used. If you wanted to travel somewhere, then also you will have to get a COVID test done. So these swaps were also printed by using 3D printing. So these are some of the applications of 3D printing when they were used in the COVID also. Even I was showing you some in construction. So similarly during COVID, these 3D printing printable isolation wards were also used. These were all done by 3D printing. Isolation wards, totally 3D printed. So isolation wards were also 3D printed. Some other applications were some parts of drones. The drones were used for carrying medicines, for carrying foods. Then these drones were also used for disinfection, for disinfecting various parts. So a lot of 3D printed parts. Lot of parts of the 3D, these drones were also made by 3D printing. So dear participants, as I told you, these are the 3D printers we have at NITER. So this one is selective laser melting printer. This is a metal printer, actually very costly in crores. So here the input powder is in the form of a powder. A metallic powder can be used, and you have to give the drawing. And this is the pen drive is fed here. You put the powder, and the product is 3D printed. And this is again a second type of 3D printer we have. This is polymer based 3D printer. This is a simple printer. So the drawing is made here and fed inside this printer. ABS polymer based printer is there, rapid prototyping machine. This is not very costly. And this is a sample one of my MTech student have made. This is how the 3D printing comes. So the base is the metal plate. I have given this, we gave this command of tensile pieces. These are simple rectangular pieces, and these were the pieces for wear testing. So we had made a drawing on this page, and the drawings were given, and you can see the by using this metal 3D printer. By using this metal 3D printer, this printing was obtained. If you see here, then the powder here, the powder is steel. Steel was used. 174 PS stainless steel was used. So basically, the powder is sprayed in the form of a layer. Using the laser, it is cut in the specific shape, and we get this product. So you just remove these samples from the base plate, and your final product is ready. So these are the actual samples one of my student had printed on using 3D printer. So these two types of machines, they are available at NITER Chandigarh. Another we have is bioprinter. So gels and all, they can be printed here by using a bioprinter, which I told you. So inks, gels, they are used, and they can be printed on this bioprinter. So this 3D printer is also available with us. So dear participants, last 2-3 slides, then we can have 10-15 minutes of discussion. I would like to add, after 3D printing, you must have heard about this 4D printing. Anyone heard about this 4D printing? What is 4D printing? Anyone knowing anything about what is a 4D printing? So this process, this proposal of or the concept of 4D printing was first made by Professor Tibbets in 2013, not very old concept. In this, smart materials are utilized to construct 3D microstructures, which have the ability to change in the preset way as time progresses. So 4D printing is actually, if you see, the addition of something with respect to time. addition of 3D printed products with respect to time. See, just a simple concept. What was 2D printing? 2D printing is nothing but a paper on which you have printed on length and across length and breadth. And what is 3D printing? 3D printing means to the 2D print. Somebody kindly mute yourself, participants.
Participant, mute yourself, please.
Okay.
Kindly mute yourself, participant, please.
Yes. So in 4D printing, in 3D printing, you give it a height. So if you have a 3D product and it changes its shape or structure or some other functionality with respect to time, then we call it as 4D printing. So what is 4D printing? A 3D printed product which changes some its shape or structure or functionality with respect to time is known as a 4D printed product. So according to Zhong and colleagues, 4D printing is articulated as the additive manufacturing technique that incorporates intelligent materials into the primary framework of materials used for creating 3D printed structures. So how does it work? That means that the characteristics of these objects, including color, size, form, they are subject to alteration due to changing environmental factors and triggers. Have you seen some sort of jellies? Let us suppose when the temperature increases, they expand. So they change their shape. So if it is a 3D printed product and it changes its shape with respect to any external factor, then we call it as 4D printing. Now this external factor can be pH values, it can be water, it can be temperature, it can be pressure. You must have seen certain jellies like we have it at our home. If you put water in it, the jelly expands, and when it expands, it starts giving out some smell. So that is also an example of 4D printing. A lot of applications are used. For example, a flat surface is there. When you put in water, it expands and makes some particular shape. So on the net, you will see a number of applications of 4D printing. Basically, first of all, you will print it by using 3D printing. Then under certain external pressure, it will change. So when I was reading about this 4D printing, I came through a paper, a very good paper was there. In that paper, it was written that they had used this, they had made some tablets by using 3D printing, medicines they had made by using 3D printing. Now the functionality of that tablet was that it was 4D tablet. Why it was 4D tablet? Because it could change its shape under certain pH levels. So what they were using, I will give you the reference. I think I have mentioned it somewhere. I will give you the reference of that paper. So basically what they were doing, they had used that medicine for treatment of cancer or some other medicines. So that tablet you will eat, that is a 4D tablet. And when it goes inside your body, where the pH level is, let us say, less than 7, acidic, let us say it is 3, then the amount of medicine which will come out from the tablet will be different. And when it is in certain part of the body, like to say intestine or some other part of the body where pH level is more, there I want that if the pH level is greater than 7, then this much amount of medicine should be released from that tablet or from that capsule. So this is how they are using 4D printing. That means the release of medication inside the body will be different depending upon the pH level of the body. You understood the concept? Basically, it is a 3D printed medicine. When it will go inside your body, depending upon the pH level, because the external factor here is the pH level. So depending upon the pH level of your body, it will release different amounts of medicines. So the setting of that medicine is done according to the pH level. Similarly, there are certain sensors which are 3D printed. If the light is there, it will give you different functionality. Or if the pressure is increased or pressure is decreased, it will give you different functionality. So this is the concept of 4D printing, means changing anything like color, shape, size, form, subject to some external factor. some external environment factor, which can be the pH level, which can be under the pressure, under water, under temperature fluctuations. So dear participants, you can see a number of applications where now this 4D printing is also being used. So this is the 4D printing technologies. It has been used for, if you see here, I will not go in details, but you can read more about that. So they have been used by FDM method, EBM, SLA, inkjet. So these, first of all, this will be prepared by any of these methods, SLS or other methods. So there are 3 different types of applications. Shape memory, that means they change the shape in the influence of light or under the influence of magnetic field also, or under the influence of electric field. And they are self-filling type, under the influence of heat. Then there are another type. So 3 different types of materials you can read in detail. I will give you the details of my paper also, where we have published all these different types of materials. So 3 different applications are there: shape memory, self-filling, and the metamaterials. So these metamaterials, they change under pH or humidity. So self-filling, they may change their shape or anything under electric field, under heat, light, or the magnetic field. So dear participants, this is all I have to share with you regarding the different materials. So I think, again, I have covered a number of aspects, and I think I have given you an overview of what are the different types of materials which are used, what are the different applications. So again, I have taken this table from my paper. It has just been published in one of good journals. So these are, here we have listed all the materials. You can see poly, carbon, methylene. The printing technology has also been mentioned. The thermal, what is the stimulus for them, pH value, moisture. So these are all the 4D printed smart materials and their associated stimulus for transformative properties and applications. So PNIPAA, this is a hydrogel material which has been printed by SLA technique. The stimulus is thermal, means under the influence of temperature. Its applications are in soft robotics, microfluidic devices, drug delivery devices. So you can see a number of, so like in the end, we have zirconia. Zirconia, this is used for aerospace, propulsion, bio-inspired, tough ceramic, organic hybrid materials. So these have given, this table gives you the entire details of the 4D printed materials. So dear participants, this is all from my side. These are some links. If there is time, I can run these YouTube links for you. This tells you about the 3D printing material. Otherwise, I will share this whole PPT of 83 pages with your sir, and he can share with you. I will share the PPT with you. In this, I will give the link of the paper also, which I have published for this 3D printing. So this is all from my side. I think I have been speaking non-stop for 1 hour, 20 minutes now. These last 10 minutes, I think we can have discussion and inputs from your side. See, this is what I have learned and what I have studied. And some of my students, actually, they have done some thesis on 3D printed. What we did was, we prepared some 3D printed samples, like the samples I showed you. And we compared the properties with some commercially or some other methods like subtractive manufacturing. Recently, in another one of the theses, we did coatings also on 3D printed products, and we wanted to know if we coat these 3D printed products, how it works. So this is all from my side. I think now we can have 1 or 2 questions from you. We still have some time.
Thanks, Dr. Neeraj, for such an elaborative talk on 3D and 4D printing. Really, the 4D printing is really new to me, and I feel that most of the audience is also feeling the same, that the concept of 4D printing is really new for all of us. Thanks a lot.
Thank you, Snehshil Sharma sir. Anybody else? Actually, I was also very astonished. I also knew about 4D printing, but I wanted to know what is 4D printing. But I was astonished to find that they are now using 4D printing for ailment of various disease. That means depending upon the problem inside your body, the release of the medicine will be different. So this was a new concept for me also. So it was a very interesting paper which I read about this change in 3D printing properties with respect to pH value. So thank you so much, Snehshil Sharma sir. Any other? Let me stop presenting with you. Yes, any other questions? I know it is very late in the evening. All must be very tired. Nice to see you, Avtar sir. How are
Yeah,
you?
fine, ma'am, fine.
Okay. Any questions from anybody?
Ma'am,
Yes, can we use, yes, Jashanpreet sir, very good question. I have not added one slide. We can use, they have used cold spray technique, sir. Cold spray technique has been used for 3D printing. We can use other techniques also like HVOF and all. But in that case, because of the different thermal expansion coefficients, the product you will obtain by 3D printing might not be very good. But definitely, but cold spray technique they have used for making 3D products. So yes, very good question, Jashanpreet sir. We can use cold spray technique, and they have actually used this cold spray for making 3D products. So Avtar sir, challenges of using 3D bioprinting for organ and tissue generation. See, already this is new thing for us. We have been using for the body parts, like if you have some bone is broken, you want to rectify that bone, and you just put a rod inside the body. But if some cells or tissues are also not working, so they take out the cell from your body, they reproduce it outside, and they replace it by the corrected part inside your body. So there are certain challenges of using 3D bioprinting for organ. The misuse can also be there. See, whenever we had talking about this 3D printing, the Casper theory, which I told you that they are using this Casper theory for some ailments, like if you have sugar or some genetic problem is there, they can change your body genes and you will get the disease will be removed. But a disadvantage is that they are not fully allowing it, because people will say, okay, that person has so much good genes, let me take those genes or DNA, and I want to become superhuman. For example, in certain region, people are having good height. So they will start modifying their genes also. So yes, there are certain disadvantages also, that there are risks also when you grow some tissue outside the lab, outside the body. You have to take a lot of care. But if it is curing your ailment, then it is good. Yes, tooth, Hamza sir, a lot of teeth, the screws which we are making inside that. One of my students tried to make some screw by using 3D printing also. So the screws and implants, the teeth implants, they are also made by 3D printing. Rather, I know one person in Mohali, he had this 3D printer. Now he has used that 3D printer for making implants. Geotechnical properties of soil, application for known for properties of soil. What do you understand by this? Known geotechnical properties of soil. Various synthetic and natural fiber filaments are available. Yes, very true, Dinesh sir. Synthetic and natural fiber filaments are available for 3D printing at affordable cost. For prosthetic arm manufacturing, 3D printing can be used. Yes, very true, Bhaskar sir. In arms, prosthetics, these have a number of applications. Dinesh sir is also correct. Is 3D tooth is also used. Sir, I did not get your question, Vijay Kumar sir. Geotechnical properties of soil, what do you understand by this? I am not very clear. Which additive manufactured materials can be used for ultra high temperature applications? So superalloys are there. A lot of nickel based and other superalloys are used. Nickel based are mostly used for high temperature, but there are superalloys also which are used for 3D printing. Yes, applications in geotechnical, everywhere 3D printing can be used, everywhere. Is it possible? Yes, high entropy alloys with the help of 3D print. No, sir. Patel, sir, at NITR, it is basically, we can use titanium, nickel, as well as steel. These type of materials can be used, but very high entropy alloys, we will have to check. But these three materials, we have already used nickel, titanium, and steel we have used. For high entropy alloys, you will first have to test a little bit of powder. If we are able to do it, then we can do it, Patel, sir. But other powders, now we have also used for two different functionally graded materials. Also, we have used functionally graded means one layer will be nickel, other layer will be titanium, other layer will be steel. But high entropy alloys, I was reading about these high entropy alloys. They have done it by using cold spray. They have sprayed high entropy alloys by using cold spray technique. But at our NITR, we have not used it for high entropy alloys. Only these three metals we have used. In all applications, 3D printing, I have covered so many of these applications.
Sorry.
So all these applications, 3D printing is used.
Sorry for interruption.
Yes.
Session will close after 2 minutes. Anybody wants to ask the question for ma'am, then hurry up.
Okay, so we have 2 more minutes. So, sir, in geotechnical, we can use various devices for 3D printing. Definitely, any devices which you use for soil mechanics and all, that devices can be easily 3D printed by using 3D printing. Any application we can use 3D printing. Yes, special tools which you use for soil engineering that you can manufacture by 3D printing also. So as sir said, only 2 minutes are left. Luckily, my charger was also the phone, this laptop remained charged. So it was lovely interacting with you all and sharing my views. See, when we are taking a session, we also learn from you. So I also came to learn a lot of things from you when you ask questions. So once again, I think it will close at 9:30. Thank you so much. I pay my regards to Khalsa College and especially to Gurbet sir for giving me this opportunity with interacting with you all. Thank you, everyone.
Thank you, ma'am. It was a wonderful session.
Thank you, Gurbet sir. Thank you, ma'am.
Thank you, ma'am. It was a great session. Dear participants, thank you for your active participation today. Tomorrow we will continue with more valuable discussions and expert talks. Thank you, madam, once again.
Thank you, sir. Thank you. Thank you, everyone.
Okay, thanks, Dr. Gurbet, for such a wonderful experts. Thanks.
Thank you, sir. Thank you, sir.
Thank you. Thank you.